NASA is known for space exploration. From landing humans on the Moon to sending rovers to Mars, the agency has spent decades pushing the boundaries of what's possible beyond our planet. But in recent years, NASA has turned its attention to this last frontier, one that's much closer to home. The Hadal zones, deep underwater extreme and inhospitable conditions of the depths. It might seem strange for NASA to dive into the ocean, but when you think about it, the parallels are hard to ignore. The deep oceans are a place of extreme atmospheric pressure, freezing temperatures, and total darkness. Conditions that are somewhat similar to those found in outer space. It was once thought that nothing could survive in such places. But what surprised everyone was that even the deep ocean is teeming with life thriving in conditions that was once thought impossible. Creatures that glow in the dark, survive extreme pressure, and live in complete darkness. NASA's interest is finding the same kind of life that could be lurking on other planets or moons, like Saturn's moon Titan, which has an underground ocean that could sustain life. NASA's shift to the deep sea. But NASA's interest in the ocean isn't new. In fact, it dates back to the 1960s, during the height of the space race. As humanity was reaching for the Moon, some began to realize that the ocean could teach us valuable lessons about surviving in extreme environments. The challenges of operating in the vacuum of space, extreme pressure, isolation, and limited resources are eerily similar to those found in the deep sea. Let's jump back to the 1960s. While NASA was busy sending astronauts to the Moon, the US Navy was launching its own ambitious project, SEALAB. This program aimed to study how humans could live and work underwater for extended periods. The idea was simple. If we could survive in the ocean's depths, we could survive in space. SEALAB 2 launched in 1965, reached a depth of 205 feet. For weeks, aquanauts lived in an underwater habitat, conducting experiments and testing new technologies. It was a groundbreaking achievement, one that proved humans could adapt to life in extreme environments. But not all missions were successful. In 1969, SEALAB 3 ended in tragedy when a fatal accident claimed the life of an aquanaut. The program was eventually decommissioned, but its legacy lived on. The lessons learned from SEALAB would go on to influence future underwater and space missions. Testing in extreme environments using latest equipment. Today, NASA continues to use the ocean as a testing ground for space exploration. One of the most famous examples is the Aquarius Reef Base, an underwater laboratory located 62 feet below the surface off the coast of Florida. This is home to NASA's NEMO missions, short for NASA Extreme Environment Mission Operations. Here, astronauts practice everything from spacewalks to equipment repairs, all while dealing with the same disorientating effects of working in a low-gravity environment. It's a unique opportunity to prepare for the realities of life on the International Space Station, or even a future mission to Mars. Life inside Aquarius is anything but glamorous. The habitat is small, cramped, and filled with equipment. Every square inch is designed to mimic the conditions of space, from the confined living quarters to the reliance on life support systems. It's a place where even the simplest tasks, like eating or sleeping, require careful planning and teamwork. Using the ocean for training astronauts isn't the only interest NASA has. Now the agency wants to explore the most extreme and deepest points in the ocean looking for life. Because if life can exist here, then it means life could very well exist on other planets or moons with underwater oceans. But exploring the deep ocean isn't easy. The intense pressure and corrosive saltwater make it one of the most challenging environments on Earth. Over the years, NASA has developed advanced probes designed to withstand these conditions. But not all of them have been successful. Some prototypes have failed under the immense pressure, while others have pushed the boundaries of what's possible. One of the deepest and most mysterious Hadal zones is the Mariana Trench. Located in the western Pacific Ocean, this massive trench stretches over 1,500 miles long and 43 miles wide. To put that into perspective, it's 120 times larger than the Grand Canyon. But it's not the size that makes the Mariana Trench so fascinating, it's the depth. The lowest point in the trench, known as Challenger Deep, is nearly 7 miles below the ocean's surface. At these depths, the atmospheric pressure is a bone-crushing 15,000 pounds per square inch. To survive here, you'd need a submarine or a special vessel specifically built to withstand the pressure. And only 3 people have been to the bottom of Challenger Deep. Back in 1960, 2 men did what many thought was impossible. Don Walsh, a US Navy lieutenant, and Jacques Piccard, a Swiss engineer, climbed into a peculiar-looking submersible called the Trieste and embarked on a journey to the deepest part of the ocean. The Trieste was no ordinary submarine, it was a bathyscaphe, a deep-diving vessel designed to withstand the crushing pressure of the deep ocean. Its massive float was filled with gasoline for buoyancy. Attached to the bottom of the float was an 8-feet diameter pressure sphere, which was made of 2 hemispheres of 3.5-inch thick steel welded together. It was just large enough for 2 people and specially designed to protect Walsh and Piccard from the immense pressure outside. As they descended, the light from the surface faded and the temperature dropped to near freezing. The pressure outside increased to over 1,000 atmospheres, enough to crush most submarines like a soda can. But the Trieste held firm. After nearly 5 hours, Walsh and Piccard reached the bottom of Challenger Deep, 7 miles below the surface. They were the first, and for decades the only, humans to ever visit the deepest known part of the ocean. What they found was surprising. Despite the darkness and pressure, life existed even here. They spotted a flatfish and other organisms, proving that life could thrive in the most extreme environments on Earth. Walsh and Piccard's journey was a milestone in exploration, proving that humans could reach the deepest parts of the ocean. But in 2012, another explorer took up the challenge, James Cameron, the filmmaker behind Titanic and Avatar. Cameron's vehicle, the Deep Sea Challenger, was a marvel of modern engineering. Unlike the bulky Trieste, this sleek, vertical submersible was designed for speed and efficiency. It was equipped with state-of-the-art cameras and scientific instruments, allowing Cameron to capture stunning footage and collect valuable data during his descent. On March 26, 2012, Cameron piloted the Deep Sea Challenger to the bottom of the Challenger Deep, reaching a depth of 35,787 feet. He became the first person to complete a solo dive to the deepest part of the ocean, and only the 3rd person in history to ever go there. What Cameron found was both awe-inspiring and humbling. The ocean floor was a desolate, otherworldly landscape, but it was also teeming with life. He documented strange, never-before-seen creatures like the squid worm, proving once again that life can thrive in the most extreme conditions. Cameron's expedition wasn't just about breaking records, it was about advancing our understanding of the deep ocean. His team collected valuable scientific data, including water samples, sediment cores, and high-resolution maps of the seafloor. Together, the journeys of Walsh, Piccard, and Cameron remind us that the ocean's depths are as mysterious and uncharted as the far reaches of space. And it's the big reason why NASA is exploring both places. NASA's Jet Propulsion Laboratory has a long history of designing robots for extreme environments, from the Mars rovers to probes exploring the icy moons of Jupiter and Saturn. These same principles, autonomy, durability, and precision, are also critical for exploring the deep ocean. While NASA itself hasn't directly designed deep-sea probes, it has contributed technology and expertise to oceanographic projects. For example, NASA's JPL collaborated with Woods Hole Oceanographic Institution on the development of Orpheus, a next-generation autonomous underwater vehicle designed to explore the Hadal zones. Before Orpheus, Nereus was designed and built. It was a hybrid, remotely operated vehicle capable of reaching the deepest parts of the ocean. In 2014, Nereus was lost during a mission to the Kermadec Trench, likely due to a catastrophic implosion caused by the immense pressure at nearly 32,800 feet. Creatures in the veins of the Earth. Deep within the ocean, in places where the Earth's crust is thinnest, lies a hidden world unlike anything we've ever seen. In 2024, a probe chipped away at volcanic crust on the ocean floor, revealing an ecosystem thriving in the most unlikely of places, veins within the Earth itself. These creatures exist in conditions that defy logic. Temperatures near hydrothermal vents can reach over 700 degrees Fahrenheit, and the pressure is enough to crush steel. Yet, against all odds, life persists. These extremophiles, organisms that thrive in extreme environments, are a testament to the resilience of life. The creatures of the deep sea are unlike anything found on land. There are fish that glow in the dark, worms that grow taller than a person, and bacteria that survive without sunlight. These organisms have adapted to life in the harshest environments, using unique strategies to find food, reproduce, and thrive. Hydrothermal vents, for example, are hotspots of biodiversity in the deep sea. These underwater geysers spew superheated water filled with minerals, creating a unique ecosystem that relies not on sunlight, but on chemical energy. It's a completely different way of life, one that challenges our understanding of what it means to survive. Despite all our modern technology, just 5% of the Earth's oceans have been explored. It's hard to believe that 95% of this other final frontier remains untouched, uncharted, and shrouded in mystery. We have no idea what's lurking down there in the inky blackness of the deep oceans, and what kind of mysterious ocean creatures are just waiting to be discovered. But there have been a few surprising discoveries lately, and bizarre-looking sea creatures from the deep have been found. Some of these creatures look like aliens from another planet, and some of them have been around since before the age of the dinosaurs. The aptly named gulper eel is definitely an alien-looking creature. It has a huge mouth, much bigger than the rest of its body. The gulper eel's mouth is hinged, and it can open wide enough to swallow prey whole. It sounds brutal to be swallowed by such a creepy creature. However, it primarily feeds on fish, crustaceans, and cephalopods. The gulper eel can grow to about 2 to 3 feet long, and when it encounters a threat, it can inflate itself like a big black balloon, thereby making itself look bigger and scarier. It eats by scooping its prey into its mouth and then squeezing the water out through its teeth and gills. The prey is surrounded by the gulper eel's elastic skin, pressed down the throat and swallowed whole and alive into its balloon-like stomach. If you thought that creature was strange looking, wait until you see the next one. This unimaginable creature is called the headless chicken monster, and watching it swim with its weird webbed swimming fin and seeing a mouth on it like a sarlacc from Star Wars will certainly give anyone the creeps. While it does look like a creature you'd find on another planet, it's actually a species of swimming sea cucumber, and they all sport that deep red color you see. But that's not their outer skin at all. Its body is actually completely transparent, and what you're really seeing is its internal organs and skeletal structure. It can be found deep in the ocean at depths of 9,800 to 13,000 feet. However, encounters with this creature are extremely rare. It feeds by using its tentacles to collect and filter organic particles of dead plants and animals that fall to the ocean floor. But as creepy as it looks, the headless chicken monster might not be the weirdest thing you'll find down here. In the murky depths of the ocean, an ancient predator lurks, the frilled shark. These scary-looking sharks have been spotted as deep as 5,150 feet. It has an ancient lineage dating back an estimated 80 million years. This means they were swimming around in the oceans when dinosaurs were still walking the earth. It can grow to about 7 feet long and gets its name from the frilly appearance of its gills. Although it's called a shark, these animals swim much like an eel. They mostly feed on squid and usually swallow their prey whole. And unlike most sharks, the frilled shark's jaw structure sets it apart from the others. Open its creepy mouth and you'll see 300 backward-facing needle-like teeth lined up in rows, which allows the frilled shark to trap and consume its prey very effectively. Once the prey is in its mouth, there's no coming out against those rows of teeth. It's probably not the most aggressive deep-sea animal, but there are some aggressive creatures down here that are very dangerous and should be avoided at all costs. This is the Mantis shrimp, which has been around for a very long time, with a fossil record dating back some 400 million years. Not only do these vibrant colored creatures have the most advanced eyesight in the animal kingdom, able to recognize up to 12 primary color wavelengths compared to the 3 red, blue, and green wavelengths that humans can see, some of these prize fighters have club-like appendages that they use to bludgeon and smash their prey to pieces. And they have a super Mike Tyson knockout punch, to be sure. At just 6 inches long, they can strike at the speed equivalent to a .22 caliber bullet, enough to crack aquarium glass and shatter the shells of their prey. In a fraction of a second, the extreme pressure from their punch creates a cavitation bubble that boils the surrounding water and implodes into a ball of sound and light, creating temperatures so hot they reach 7,000 degrees Celsius, about the same temperature as the surface of the sun. Their punch is so devastating that it can literally knock the arms off its prey. There are many creatures that are called living fossils, and the vampire squid is another one of them. Scientists named this animal Vampiroteuthis infernalis, which means vampire squid from hell. However, that name is misleading because, for one, it's not a squid, and it's surely not a vampire. The vampire squid uses a pair of retractable, filamentous structures that extend well beyond the reach of its arms to capture what's known as marine snow, a term used to describe the shower of organic material that falls from upper layers of the water column to the deep sea, including dead plankton and other organic material. The vampire squid has a gelatinous body that is dark red or black in color. Its unique characteristic is its cloak-like webbing that connects its 8 arms, giving its vampire-like appearance. When threatened, it can invert this cloak, showing a larger, spiky appearance to ward off predators. It's been around for a long time, with fossil records indicating that its ancestors date back at least 300 million years, meaning the vampire squid is another creature that's outlasted dinosaurs and many other forms of life. While the vampire squid inhabits the abysmal depths, cloaked in black and thriving in the dark, it shares a surprising similarity with another remarkable creature from the sea. The Japanese spider crab is part of the group known as Brachyura, or true crabs, which originated during the Jurassic period, approximately 200 million years ago, and has adapted well to its environment. The Japanese spider crab holds the record for the longest leg span of any arthropod. When measured from claw to claw, these giant crabs can reach up to 12.5 feet. However, their bodies are only about 15 inches wide. Japanese spider crabs inhabit the depths of the Pacific Ocean around Japan, as their name suggests. They've been found as deep as 2,000 feet below sea level. Japanese spider crabs are omnivores and scavengers. Their diet consists of plants, algae, mollusks, and the carcasses of dead animals. Despite their monstrous appearance, Japanese spider crabs are known to have a gentle disposition. However, due to their size and habitat, you're probably not going to see one in a home aquarium. The oversized Japanese spider crab is certainly an interesting creature, but now it's time to take a look at a more ancient species of animal. The horseshoe crab has been around for more than 445 million years, long before the ages of dinosaurs, and it's still around today. This means that the mighty horseshoe crab has survived at least 4 of the Earth's biggest mass extinction events, including the devastating Chicxulub event that nearly wiped out all of the dinosaurs, and their physiology has remained largely unchanged, making them a living fossil. Researchers say it's because of the horseshoe crab's ability to eat just about anything they can catch. The horseshoe crab also has special copper-based blue blood that can coagulate around invading bacteria, thereby protecting the rest of the horseshoe crab's body from toxins. Despite their name, horseshoe crabs aren't really true crabs, or even crustaceans. These brackish water arthropods belong to the family Limulidae and are really chelicerates, which are more closely related to arachnids like spiders, scorpions, and ticks. But despite their scary-looking barbed shell, they're harmless to humans. It's hard to believe the horseshoe crab has been around so long, but there's another prehistoric deep-sea creature that beats it on the prehistoric timeline. Meet the chambered nautilus, an ancient deep-sea creature that has a fossil record dating back a whopping 500 million years. To put that in perspective, they were flourishing in the deep oceans 300 million years before the age of the dinosaurs. There are only 6 species of chambered nautilus, and they haven't changed much over time. Their shells are the most distinctive feature, which are spiral-shaped and divided into multiple chambers, hence the name chambered nautilus. As the nautilus grows, it creates new, larger chambers and moves to the outermost chamber. These creatures are scavengers that feed on dead fish and other organic detritus that sinks to the bottom of the ocean floor. It's got a sharp beak like an octopus and 90 tentacles. They can live up to 20 years, which is quite long for a cephalopod. Moving from the spiraled elegance of the chambered nautilus, we dive deeper into an unlikely underwater world to meet a less known but equally fascinating creature. Just one look at the Yeti crab and you understand where it gets its name from. It's covered in what looks like silky, blonde, hair-like strands called setae. These features, reminiscent of the abominable snowman or Yeti, make it one of the most unique-looking sea creatures. But the most incredible thing about the Yeti crab is that they inhabit some of the most inhospitable places on Earth, in the deep sea near hydrothermal vents. These vents spew out superheated, mineral-rich water, creating an extreme environment that few organisms can tolerate. The other remarkable thing about these hardy creatures is how they eat. Those so-called hairs on their claws serve as a habitat for chemosynthetic bacteria, which convert the inorganic chemicals from the hydrothermal vents into organic matter through a process called chemosynthesis. The Yeti crab farms these bacteria by waving its claws through the mineral-rich water, providing them with nutrients. In return, the crab consumes these bacteria, which helps it survive in a food-scarce environment. And while we're on the subject of crabs, this next one is really interesting, if not downright peculiar. This is the box crab, and like so many other creatures in the deep sea, he's a master of disguise and has a very bizarre mating ritual. The box crab grabs its mate and carries her around, and will even bury her to protect her. The much smaller female doesn't seem to mind what's going on, and he'll carry her around until she molts her shell. Not much more is known about this elusive sea creature, other than they're very tasty, being a relative to the king crab. That is, if you're able to catch one at such depths in the ocean. But there's not just unique crabs and shrimp in the deep oceans, there's some strange versions of sharks and fish down there too. Meet the thing of nightmares, the goblin shark. One of the most striking features of the goblin shark is its distinct, bizarre appearance. It has a long, flattened snout, which gives it a goblin-like look, hence its name. Its jaws can protrude forward to catch prey, which is an adaptation seen in very few shark species. The goblin shark is often referred to as a living fossil, like many of these creatures, because it belongs to one of the oldest lineages of sharks. It's estimated to have been around for over 125 million years, making it a true relic from the past. Goblin sharks are primarily found in deep ocean waters, ranging from 1,000 to 4,000 feet below the surface. This habitat makes them extremely elusive, and as a result, they're rarely seen by humans. But deep beneath the ocean's surface, where sunlight scarcely reaches, live other creatures so otherworldly and unique that they're rarely seen by humans at all. Meet the giant oarfish, the longest bony fish in the world, with some growing from 33 to 56 feet in length. That's a big fish. Oarfish live in the deep sea, usually at depths of 650 to 3,280 feet, though they're occasionally seen at the surface, often when they're sick or injured. However, this brings us to a very strange thing about these creatures. According to Japanese legend, the oarfish are said to beach themselves before an earthquake or a tsunami, and are called messenger from the sea god's palace, though the scientific community remains skeptical of this claim, as there's no solid evidence linking the two phenomena. One of these rare creatures was just spotted recently in shallow water by a group of divers. There is still much we don't know about this elusive deep-sea fish. Speaking of things hiding away down deep, we can't forget about stingrays, and this one is definitely unique. As their name implies, deep-water stingrays are found in very deep parts of the ocean. They typically live in depths ranging from 660 to 6,600 feet. They're also known as six-gill stingrays because they have 6 pairs of gill slits on their undersides, while most other rays and sharks only have 5. Unlike many stingrays, which have broad, flattened bodies, deep-water stingrays have a more rounded or wedge-shaped body. This helps them move through the water in the deep sea. They possess a long, whip-like tail that can be several times the length of their body, and like other stingrays, some species also have a venomous barb near the base of their tail. Deep-water stingrays are carnivorous and feed primarily on small fish and invertebrates, using their strong jaws to crush their prey. And here's a surprising thing you might not have known. Like other stingrays, the female gives birth to live young. The deep-water stingray has also been around a very long time, with fossil evidence suggesting they first appeared around 420 million years ago. Take a look at what's been aptly named the sea spider. Sea spiders are fascinating creatures, but fear not, they're not true spiders belonging to the arachnid family, but belong to a separate class called Pycnogonidae in the phylum Arthropoda. The giant sea spider can reach leg spans of nearly 28 inches, although most species are much smaller. Despite their long legs, their bodies are quite small, often not much larger than the size of a human thumb. In fact, sea spiders have no abdomen, and their bodies are reduced and cylindrical. Their organs are stretched throughout their bodies, even into their legs, because their bodies are so small. One of the most incredible things about these delicate-looking creatures is that their lineage is quite old, with fossil records dating back to the Silurian period, around 430 million years ago. The ancient lineage of these creatures means they've also survived several mass extinction events. These creatures are generally carnivorous, feeding on jellyfish, sea anemones, sponges, and other soft-bodied invertebrates. They have a long proboscis like a mosquito that they use to suck nutrients out of their prey. We've been able to find a lot of rare animals down in the deep, but there are some that are so rare, some people think they don't exist or have become extinct. We're talking about the bigfin squid. Sightings of bigfin squids are extremely rare. Until recently, there had only been about a dozen confirmed sightings worldwide. In 2020, scientists reported the first ever sightings of bigfin squids in Australian waters. They inhabit the deep sea, found at depths ranging from 3,280 to 15,500 feet. It sounds like a giant creature. However, it's in the same size group as the sea spider. The main body section itself is not very large and usually measures about 6 to 7 inches in length. The most incredible thing is that the bigfin squid's arms and tentacles can be up to 20 times the length of their main body section, making their total length up to 26 feet long. These creatures are rare, and we don't know much more about them. However, that can change at any time. As we resurface from our incredible journey through the deep, leaving the world of giant crabs, ancient horseshoe crabs, mysterious squids, and elusive sharks behind, we're reminded of just how much remains unexplored in the depths of our planet's oceans. A reflection of otherworldly potential. If life can thrive in the most hostile corners of our planet, what might await us in the icy oceans of Europa or the methane seas of Titan? These deep-sea creatures are more than just survivors, they're a glimpse into the potential for life beyond Earth. The ocean and space may seem like opposites, but they're more connected than we realize. Both are frontiers of exploration, filled with mystery, wonder, and the potential for discovery. By venturing into the deep sea, we're not just learning about Earth, we're preparing to explore the cosmos. Europa is one of the 95 moons of the gas giant Jupiter. a mysterious, cold world with a diameter of 1,940 miles, which is about 90% the size of our Moon, entirely covered in ice, exposed to incredibly intense cosmic radiation, and with extremely low surface temperatures that drop below -150 degrees Celsius. At first glance, it may seem like a barren, dead world, but currently this icy moon is considered one of the most promising places in search of extraterrestrial life. Here's why. In 1997, while following an extremely low trajectory just 125 miles above Europa's surface, the Galileo spacecraft managed to capture an extremely strange phenomenon. In one section of the moon's surface, there was something resembling a water vapor eruption. At the same time, scientists observed an anomaly in the readings from Galileo's magnetometer. Analysis of this anomaly showed that this kind of phenomenon can occur when water vapor molecules are ionized by sunlight. This means that the Galileo spacecraft didn't just fly near a water vapor eruption from beneath Europa's ice, but flew directly through it. Later, the Hubble Space Telescope, when studying the icy moon, provided new evidence of geysers on its surface. In 2013, it managed to take several photographs of the moon where it's possible to spot traces that were presumably left by giant geysers in the section on the lower left. Scientists believe that these geyser jets reach several hundred kilometers before crashing back down to the moon's surface. According to calculations, every 8 minutes, there's enough water ejected from beneath the ice to fill an Olympic swimming pool. Indeed, there's plenty of liquid water out there. The depth of Europa's subglacial ocean may reach 60 miles, and the total volume is likely to exceed double the volume of Earth's oceans. But geysers are not the only clue the scientists have. It was recently established that Europa's crust rotation speed varies. Sometimes it moves faster, sometimes slower. This means that the crust movement differs from the speed of rotation of the moon's internal part. The cause is attributed to the gravitational influence of Jupiter. The tidal forces of the gas giant cause deformation, which makes the icy crust slowly and unevenly slide over the subglacial ocean. This is direct evidence that between the icy shell and the solid core of the moon, there's a vast ocean of liquid water, which makes this chaotic movement of the icy shell possible. Additionally, Jupiter's gravitational force may also be a source of energy for the subglacial ocean, keeping it in a liquid state. The side of the moon closer to Jupiter experiences stronger gravitational pull from the gas giant than the opposing side. This creates a stretching effect, causing fractures to appear on the surface of Europa. Fractures that were first seen by the photos shot by Galileo. Moreover, it's likely that the moon is heated from within due to tidal processes and friction caused by its flexing. Galileo also detected a strange disruption in Jupiter's magnetic field structure in the space surrounding Europa. This anomaly suggests that the magnetic field is distorted due to its interaction with an electrically conductive liquid beneath the moon's surface. Based on Europa's icy composition, scientists believe that the most likely material responsible for this magnetic signature is a global ocean of salt water, hidden beneath a massive ice sheet, estimated to be about 10 to 15 miles thick. Any radiation or other external influence cannot reach this water world, which means that there is no threat to potential life and its evolution. But why do scientists believe that in such extreme conditions, far from the sun, under a thick ice layer, it is nonetheless possible for extraterrestrial life to exist? And how complex might it be? We already know that liquid water is essential for life to emerge, and Europa has more than enough. Furthermore, the water on Europa is in constant motion, interacting with the silicate mantle, which means that mineral compounds are being washed away, providing resources for potential life forms. Thermal energy, which is another key component for life to exist, is present inside Europa due to gravitational deformation processes. Sunlight is not always required. Additionally, there are hypotheses that volcanic activity could be another source of energy. If there are volcanoes harbored beneath the ice, they could create the necessary conditions for life. Examples of this exist on Earth, where volcanic rocks on the ocean floor interact with salt water, creating chemical reactions that generate energy and enable microbes, worms, and other organisms to thrive. Similar deep-sea vents might exist on Europa. Additionally, the most important condition for the emergence of life is the presence of chemical elements, the fundamental building blocks for all living things. Recent studies suggest that these elements are indeed present on Europa. Just recently, the Hubble Space Telescope managed to detect carbon dioxide out there. The data analysis indicates that the carbon dioxide likely originated in Europa's subsurface ocean, rather than arriving on a meteorite or other external sources. In an infrared image taken by Hubble, a white spot of carbon is visible against the blue surface of Europa. Notably, this carbon dioxide was deposited in a geologically recent time frame, and this intriguing discovery suggests that, as we speak, something may be alive beneath Europa's ice. In addition to carbon dioxide, traces of hydrogen peroxide have been found, which is essential for a process known as methanogenesis, the production of methane by anaerobic archaea. Another astonishing discovery was made by the Juno spacecraft. On September 29, 2022, while flying over Europa just 220 miles above its surface, it detected atomic hydrogen ions emanating from the Moon's atmosphere, indicating a significant amount of oxygen produced as a result of radiation particles bombarding the satellite's surface, subsequently breaking water molecules into hydrogen and oxygen. Researchers estimated that Europa produces around 12 kilograms of oxygen per second, enough oxygen to supply 1 million people to breathe for an entire day. Scientists have speculated that some of this oxygen could be reaching the subsurface ocean through geological processes. If this is the case, the presence of oxygen in Europa's ocean further increases the chances of life there. Finally, for life to begin and evolve, it's crucial to have a stable environment, and most importantly, a vast amount of time, something Europa has had an abundance of. According to the latest estimates, this ocean could have existed as long as our solar system, more than 4 billion years. Throughout this time, the subsurface ocean has been isolated underneath enormous ice sheets, providing a stable, safe environment for any potential life forms to emerge. Given such an immense time span, even in less favorable conditions than those on early Earth, the probability of life emerging remains pretty significant. And if life does exist on Europa, what might the scientists expect it to look like? It's believed that any forms of life discovered over there would likely be primitive, similar to bacterial life that emerged from Earth's deep-sea vents. While some scientists involved in the project dedicated to studying Europa claim primitive life forms as their most optimistic expectations, others, on the contrary, take it a step further, hoping to discover complex multicellular life. According to their hypothesis, something akin to chemotrophic bacteria might inhabit Europa's subsurface ocean, forming layers of organic deposits on the ocean floor. Other life forms would feed on these deposits, analogous to herbivores on Earth. Respectively, they would likely be predators, possibly resembling sharks. These creatures would have to thrive in complete darkness and under the immense pressure created by the thick ice and ocean depth. While such speculation may sound fantastical, it's not entirely unfounded. Another compelling argument in favor of the feasibility of the hypothesis that there might be life under the crust of the icy moon is one of the most significant geographical discoveries of the late 20th century. In 1973, a research expedition in eastern Antarctica discovered one of the largest freshwater subglacial lakes in the world, named Lake Vostok, which we discussed in another video. It's buried beneath 2.5 miles of ice and has been in total isolation from the outside world for millions of years. Water samples from this lake revealed the presence of unique bacteria. Conditions in Lake Vostok are believed to be not too dissimilar to those in Europa's subsurface ocean. This unique finding on Earth gives us reason to believe that life could indeed exist in such seemingly dire and extreme conditions. In order to determine whether Europa's ocean could conceive and support life, NASA launched the most ambitious planetary exploration mission in human history, the Europa Multiple Flyby mission. The star of this mission is the Europa Clipper spacecraft. Despite the complexity and risks of the mission, there are high hopes for Europa Clipper, and it's the most technologically advanced spacecraft ever sent to Jupiter. The launch took place on October the 14th of this year. The spacecraft was launched into space by the SpaceX Falcon Heavy rocket, which allowed Europa Clipper to follow a trajectory that will eventually take it to Jupiter. This is the largest space vessel NASA has ever sent to explore a planetary body, weighing 12,500 pounds at launch. With its antennas and solar panels fully deployed, it spans 100 feet from one end to the other and is about 58 feet wide. That's larger than a basketball court. The solar panels were given a special role to play. They were built at Kennedy Space Center in Florida and measure about 46 feet long and around 13 feet high. These panels are the largest ever developed by NASA for a planetary mission. This is no coincidence. The size is necessary to capture as much sunlight as possible while exploring a moon that's 5 times farther from the Sun than Earth. Europa Multiple Flyby mission has become NASA's most expensive planetary mission in history, costing $5.2 billion, which is about half the cost of the Hubble Space Telescope and twice as expensive as NASA's most recent Mars rover. Europa Clipper carries 9 advanced scientific instruments on board, which will begin working in sync as soon as it reaches Europa. Among them is a radar designed to penetrate the ice. It will send radio signals into Europa's icy shell and analyze the reflected signals to reveal the moon's internal features. High-powered cameras will map Europa with far greater resolution than previous missions. The best of these cameras will be able to detect features on the moon's surface as small as 20 inches in certain areas. These images will be 12 times clearer than the most detailed images taken by Galileo. Meanwhile, an infrared thermal imaging system will attempt to search for warmer areas on Europa where liquid water may be close to the surface or may have been expelled. As the radar and cameras will be observing from a distance, other instruments will directly sample the surrounding environment, collecting gas and dust from space to determine their chemical composition. In addition to the scientific instruments, Europa Clipper, like many past robotic explorers, carries messages from Earth. This time, it includes a poem by US Poet Laureate Ada Limon, signed by millions of people from nearly every country in the world. Their names were inscribed on a microchip attached to a tantalum plate that seals the spacecraft's electronic storage. The plate also features wave-like patterns of water with the word water spoken in over 100 languages. Quite an inspiring touch, given the spacecraft's destination. Europa Clipper will need to travel a long distance. The spacecraft will cover nearly 1.8 billion miles before it reaches Europa. Traveling such an enormous distance using only its engines for acceleration would be impossible, as it would require an unimaginable amount of fuel. As such, Europa Clipper will use the gravitational forces of Earth and Mars to accelerate. Next year, it will pass by Mars, then follow a trajectory resembling an elongated loop, returning to Earth in 2026 before heading toward Jupiter at an even greater speed. It's expected to reach its destination in 2030. As it approaches the target, Europa Clipper will fire its engines for 6 to 8 hours to slow down and enter the orbit around the planet. This will set the spacecraft up to orbit Jupiter 49 times, getting as close as 15.5 miles to Europa. However, even way before slowing down to orbit around the gas giant, Europa Clipper may face serious challenges. Jupiter emits the highest levels of radiation in our solar system, excluding the Sun. As Europa orbits this gas giant, it passes through these hazardous radiation belts, posing risks to spacecraft. To protect Europa Clipper, its electronics are housed in a storage compartment made of dense aluminium and zinc walls, which should offer adequate protection, though some risks remain. The mission around Jupiter will last 4 years, during which Europa Clipper will make 49 close flybys of the icy moon, collecting all kinds of data. The main objectives of this mission will be to determine the exact thickness of Europa's ice shell and the ways it interacts with the ocean beneath, investigate its composition, and characterize its geology. Additionally, using its powerful cameras, the spacecraft will identify the best site for a future landing module, one that would be the most promising for further research, such as areas where the ice is thinner compared to other regions. At first glance, it might seem that Europa Clipper has little chance of finding extraterrestrial life while studying the moon from afar. However, that's not entirely true. The spacecraft will also search for the very thing that triggered active research of this icy moon: giant geysers. Scientists hope Europa Clipper will have a similar experience to Galileo, which passed through the plumes of water vapor emitted by a geyser. If life, whether bacterial or multicellular, exists in Europa's sub-ice ocean, traces of this life could be found even miles above the surface of the satellite. Presumably during geyser eruptions, water and ice particles shoot up to dozens of miles above the moon's surface. Bacteria could easily be frozen in ice particles and delivered straight to Europa Clipper via the plume as the spacecraft passes by. Of course, the chances of an event like this are extremely slim, but should not be ruled out. Everything ejected from the depths of Europa could carry evidence of potential life if it exists. After completing its mission, in 2034, Europa Clipper will make a planned crash landing on Ganymede, the largest moon around Jupiter, and, as it happens, the largest in the solar system. Interestingly, Ganymede is also believed to have a subsurface ocean. However, its ice shell is very thick and may extend to depths of 100 miles, making it more difficult to study the environment beneath. Another of Jupiter's moons, Callisto, may have an even thicker layer of ice, potentially hiding an ocean beneath. Geyser eruptions have also been observed on Saturn's moon, Enceladus, but it's much farther from Earth. The same is true for Saturn's moon, Titan, which is also believed to harbor a subsurface sea. As far as Europa, we'll learn whether its oceanic world under the ice is suitable for life in just a few years. Perhaps for the first time in history, we'll discover life beyond our home planet. And no matter what predictors or speculations are floating around, we won't know for sure until we try. Titan, the largest of Saturn's 146 moons, is even bigger than Mercury. But it's no ordinary satellite. The gigantic moon is so similar to Earth, it's almost hard to believe. Not only does Titan have lakes, seas, and rivers, but it also hides a subsurface ocean of water below the icy ground. In the moon's skies, there are clouds. On its surface, organics. It rains on Titan. Liquid bodies replenish lakes and seas, and then evaporate, launching an Earth-like hydrological cycle. The atmosphere of nitrogen and methane that envelops the satellite is thick enough for you to safely stroll around its surface without a pressure suit. But that's only if Titan wasn't as cold as minus 290 degrees Fahrenheit and had an oxygen-nitrogen atmosphere like the Earth. And if you had wings attached to your suit, you could even fly, as the moon's gravity is just 14% of the Earth's. Because of this, you would also witness rain falling in slow motion, about 6 times slower compared to Earth. Although it would be no ordinary rain. On Titan, it rains liquid methane, and its droplets are roughly 50% larger than raindrops we see on our planet. Titan is located some 750 million miles from Earth, where it revolves around Saturn in about 16 days. Titan is tidally locked to the 6th planet. But even though one of its sides is always facing Saturn, the satellite still has intricate weather patterns. Saturn's largest moon receives 100 times less solar energy than our planet, and it has a thick atmosphere extending 10 times higher into space. In these conditions, not much light can get through and reach the surface. For the first half of Titan's day, which is equivalent to 16 Earth days, its surface is bathed in a faint orange haze. Looking through this haze would be like trying to see beyond thick fire smoke. The skies during this part of the day could be 100 to 1,000 times dimmer than here on our planet in an afternoon. And the other part of the day brings total darkness to the surface. But even if it was bright enough, you still wouldn't see Saturn from the surface of Titan because of the haze. Interestingly, daytime isn't the brightest part of the moon's day. According to computer simulations, the brightest it gets on this mysterious world is during twilight, up to a factor of 200 compared to daytime. This is something that happens because of the way light is scattered by the haze particles in the atmosphere. And since Titan is tidally locked, with a permanent daylit side and night side, there is also a permanent twilight zone, a border in between the two sides called terminator. Titan, like Earth, experiences eclipses, which can last up to 6 hours. This is like having a second night in the middle of the day. Of course, you'd only notice it if you were on the side of Titan facing Saturn. Otherwise, a solar eclipse would happen during nighttime. Understanding this is important, as it tells scientists how much light Titan's atmosphere and its surface receives from the Sun, which dictates what conditions potential life on Titan would have to live on. Just recently, the James Webb Space Telescope was able to detect clouds that form in Titan's lower atmosphere during late summertime, when its surface absorbs more heat. And this means that the moon has seasonal weather patterns, just like scientists have predicted it. Titan's tilt relative to the Sun closely resembles that of Saturn, so both celestial bodies experience seasons of approximately equal duration, changing about every 7 Earth years. Although at a slow rate, seasonal shifts bring change in weather on Titan. When the Earth's axis is tilted neither away nor toward the Sun, something interesting happens. Imagine a line that cuts through the north and south poles, dividing the planet in half. During this time, occurring twice a year, night and day have about the same length all over the world. This phenomenon is called the equinox, and Titan experiences it too, although less frequently, about every 15 years. But when this time of the moon's year comes, enormous clouds of methane form in its equatorial regions, bringing about severe windstorms. During summer on Titan, the wind blows stronger. During the Cassini mission, scientists saw waves on Titan's lakes, and they were unlike any waves here on Earth. Titan's weak gravity allows these waves to be much bigger, about 7 times taller than waves in the Earth's oceans. But they move more slowly, up to 3 times slower. Winds on Titan also fuel powerful dust storms. Something like this happens in arid areas on Earth too, when big dust clouds form right before storms. The only other place in the solar system this phenomenon has been detected is Mars. This is how organics in the form of dust are scattered around Titan's surface. And although downpours are a rare phenomenon on Saturn's largest moon, when they do happen, they leave behind a fascinating footprint. Titan's rains are heavy and have a big impact on the surface. They create something called alluvial fans. These features are a bit like piles of dirt and rocks shaped like triangles. They form when water or ice flows and leaves behind the stuff it was carrying. Scientists have also detected dune fields on Titan, taking up to 13% of the moon's surface. Compared to sand dunes found on Earth, they are enormous in size, hundreds of miles long, 1.2 miles wide, and 330 feet high. There's more sand on Titan than anywhere else we know of, although this sand isn't made of silicates like it is on our planet. Instead, it consists of solid hydrocarbons that fall like rain from the atmosphere. On Earth, we understand how landforms are created through a straightforward process. Rocks break down into tiny grains. Wind carries these grains to specific areas. They pile up, and eventually they shape the land. But on Saturn's largest moon, things are more puzzling. The origin of its landforms has been a mystery because the sand grains on Titan are quite different from those on Earth. They're weaker and thought to be more temporary. However, despite this, we've observed long-lasting sand dunes on Titan. When the wind transports sand grains, they should collide with each other and the surface, which usually makes them smaller over time. So how do these grains manage to stick around long enough to form significant landforms? After studying Titan's landscape, scientists discovered something fascinating. It turns out that the moon has a special type of sedimentary process known as sintering, where neighboring grains smash together and fuse into larger, stronger pieces that are less likely to be blown away by the wind. If sand on Titan can adapt in such a way to form complex landforms, could life have adapted similarly? There are a lot of similarities between our home planet and this alien faraway world. The problem with Titan is its ingredients seem to be all wrong. What's water on Earth is liquid methane and ethane there, including its clouds, rivers, lakes, and seas. But one thing is certain, this celestial body is still active. Even liquids flowing on the surface of Titan involve complex physical processes. Similar to water bodies on our planet, methane lakes on Titan can stratify, that is, create layers depending on density difference. And not only that, but the liquefied methane and ethane lakes could potentially erupt. This happens due to the combination of methane, ethane, and nitrogen, resulting in bubbles powerful enough to shape river deltas within the moon's liquid bodies. Understanding how bubbles form in Titan's lakes helps scientists explore how liquids behave on this intriguing moon. Imagine if a submarine was sent to explore Titan's lakes one day. If it gives off heat, it could actually cause an explosion of bubbles, just like the ones scientists have discovered. So these findings not only tell us about Titan, but also hint at some surprising challenges a future spacecraft might encounter in those alien waters. Whatever life forms could potentially exist there, they would have a completely different biology, and so they would look and act like nothing we've ever seen before. According to a team of researchers from Cornell University, it's possible for cell membranes to form in the conditions present on Titan right now. On Earth, cell membranes are made up of special molecules called phospholipids. Imagine these molecules as having a head and tail. The head is a bit like a magnet, with a positive and negative side. The tail is neutral, meaning it has no magnetic quality. Imagine these molecules in water, like a sandwich with two slices of bread. The heads of the molecules are like the outer sides of the bread, and they really like the water, so they face outward. But the tails of the molecules are like the inside of the bread, and they want to stay away from the water, so they hide in the middle. This arrangement makes the membrane flexible, something that's crucial for life. If there's any form of life on Titan, it would probably need to have a similar membrane. The problem is, methane has an even distribution of electrical charges, so Titan doesn't have the right conditions to make these Earth-like membranes. Because of this, life on Titan would have to find a different way to build its cell walls. But scientists have been able to create inside-out membranes in such non-polar liquids in a laboratory, and they believe that titanium cell membranes would have a similar structure, although they would have to be composed of something else, as liquids on Saturn's largest moon probably lack phosphorus and oxygen and are too frigid for phospholipids. So what kind of a molecule could this be? Although the titanium atmosphere is mostly made of methane and nitrogen, it has traces of different compounds as well. Computer models have shown that a substance called acrylonitrile would be able to form cell membranes in a non-polar liquid methane on Titan. The Cassini mission has previously detected small amounts of acrylonitrile in the moon's atmosphere, about 10 parts per million. Even though there's a vast difference in temperature in which Earth-like membranes form and titanium membranes could form, they both share surprisingly similar qualities, like stability and internal resistance to external force. So it's possible for membranes to form in frigid temperatures of Titan's lakes and survive there. The possibility of methane-based life would change our entire outlook. Instead of focusing solely on planets in the habitable zone of stars where conditions are Earth-like, we'd also explore worlds farther from their stars where methane can exist as a liquid. Within our galaxy alone, the number of potential places to find alien life forms would skyrocket. And if life on some of these worlds has persisted for long enough to develop into complex organisms, we might find a living counterpart of an imaginary creature like those mentioned in fantasy movies and books. But Even if at this late stage of Titan's history life cannot survive on its surface, there's a subsurface ocean of liquid water hiding beneath the moon's icy coating. Scientists are trying to find out if organics can penetrate through this ice shell into the ocean. If this is something that happens on Titan, then this subsurface water could be potentially habitable. Although we still don't know much, like what the density or composition of this global ocean is, its temperature, and how it interacts with the icy crust above. Another big question is whether there's a source of chemical energy down there to allow for metabolism. But one bacterium with a rare metabolism that's been found on Earth could potentially live in the Titan's subsurface ocean. Billions of years ago, the Earth had a very different atmosphere, with high amounts of nitrogen, CO2, and water vapor, which descended to the surface, launching a life cycle. The building blocks of life on our planet may have once been the same ingredients we see today on Titan. In a way, Saturn's largest satellite is a real-life lab where astrobiologists can study how these ingredients might have played a role in the beginnings of life on Earth. Perhaps some millions or billions of years into the future, the Moon will evolve into a habitable world, teeming with Earth-like organisms. Soon, we may find out the answer to these questions. Planned to be launched in June 2027, NASA's Dragonfly robotic helicopter will search for water or hydrocarbon biosignatures potentially present on Saturn's gigantic satellite. With Dragonfly's arrival, scientists hope to uncover clues about Titan's subsurface ocean, its potential habitability, and whether the ingredients for life might indeed be present in this distant world. If we discover signs of alien life on Titan, what might these otherworldly creatures look like? Share your thoughts in the comments below, and stay tuned here for the thrilling discoveries that await us in space. Thanks for watching.